Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to impart techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is capacity modeling, the next milestone in performance engineering. Our guest speaker today is Mr. Uday Kumar VR, Center of Excellence Head, Performance Engineering, Test Automation and Service Virtualization at Wipro Technologies. Uday has more than 12 years of experience in various facets of performance engineering, SOA testing and service virtualization. He has been an active member in Thought Leadership Group for Service Virtualization and Performance Engineering at Wipro and heads the Center of Excellence. The organizations he has worked with in the past include Devon Technologies, LG CNS Global and SunGard. He had been the editor-in-chief of the performance newsletter called Performance Booster and had successfully rolled out 300 plus editions in Wipro and still going. He had been actively designing workshops for upcoming service virtualization practitioners and performance engineers, bringing in experience from various domains like BFSI, telecom and retail. So without further delay, I introduce you all to our guest speaker. Over to you there.
All right. Are you sharing the presenter mode, Mohini?
I have done that.
Thank you.
You can share your screen.
Thank you. Hello, everybody. Good afternoon to all people in India and people from good morning and good evening for people around the globe. So this is a seminar or a session on capacity modeling, which is the next milestone in performance engineering, and we have a target audience towards the performance engineers, capacity planners, or infrastructure planners. So this is eventually being now looked at a very essential item in any performance testing lifecycle. So I had the Center of Excellence in Wipro for performance testing, engineering, automation testing, service virtualization. So I'm going to talk about a few of the theories before we get on to the capacity planning per se, and then we'll take some questions. So if there are any questions, you can actually log into your question section and you can type in the question, and I'll be glad enough to answer these questions at the end of that. However, I would suggest to park your questions before you type in there. You might get answer as we in the due course of the presentation also. All right. Thank you very much. So we'll proceed further. So let's first look at the agenda or the contents that we're going to have today. We'll have an introduction, obviously, to understand, to get the context of the presentation. We'll have some amount of theory around what is a capacity planning. In general, it's all about how to plan your infrastructure capacity in the production. And most of the times, the people who validate whether the infrastructure is okay for this kind of load, for example, 100 users, 1,000 users, 1 million users, the people who validate and tell is the performance testers and engineers. So when you plan for a capacity like an infrastructure, you would definitely need the output from these performance testing validation. So let's look at the theory part of it. Then we'll see how it is done in a lab. For example, I'm going to tell you as to how did we do in the lab and the process of capacity planning, which is again an abstracted theory of how did we do, and few guidelines around capacity planning. So I'll be happy if there is any amount of takeaway in terms of how do you do the capacity planning and modeling. And it is how it is a part and parcel of a performance testing engineer lifecycle. All right, let's go forward. Now, first of all, to understand the capacity planning, you need to understand which are the key performance needs or key performance queries that is actually pushing you towards the need for the performance capacity planning. The few of the questions that I flashed you on the screen, like will the application perform in the production the similar way? How many of you as a performance engineers, you had been actually boggling with this kind of question saying that it had worked in a very lower end environment, but how will it perform in the production where the environment is also at a high end and at the same time the load is also very at a higher end. So you cannot have a complete realistic performance testing in the lab or a pre-prod environment. So these questions have to be answered. Now, where are the potential bottlenecks in the application? While you do during the performance testing and engineering itself, it's important to know that if the load is now exponentially increased, which is the first bottleneck that you would be arriving upon. So that you would know only when there is an extrapolation that you can do. Third bullet, can this application meet the required service levels? Straightforward question. Will a change in one application or an infrastructure component cascade to performance problems? The point is, like, I not only mentioned application, I mentioned infrastructure also. Let's take an example of a client, a web server, an app server, and a DB server. Let's assume that I have 20 web servers, and I'm going to probably put it into 10 web servers. I'm going to consolidate web servers into 10, which means because in all the web servers, I'm not seeing the very appreciable utilization, so I wanted to consolidate. So if I do that kind of a change, as a performance engineer, would you be able to extrapolate whether it's going to really work with the same SLA or a similar kind of SLAs? Then, which hardware solution best meets the performance and goals? Very simple. Should I buy a Dell server, or should I buy an IBM server? Should I buy a Pentium, or should I buy a Xeon, or should I buy an AMD Anthlon? So these kind of hardware solution, whenever the hardwares they release into the market, they produce something called as a PPCC benchmarks. You can look into the Google and find out what they are. So these benchmarks tell how do these hardwares perform. For example, AMD Anthlon, for example, Intel's Xeon server. So they test on a very standard application, starting from web application to any client server application, and tell you as to what benchmarks do these hardware have. Now, before even buying an infrastructure or planning for capacity, you're going to buy, let's say, 50 servers and 70 data centers, and so many virtual machines and so many cloud VM instances. So you're going to understand as to the nature of the hardware also, because it means a lot for the performance. Now, how can the service level agreements be met without overburning our infrastructure? So overbuilding our infrastructure. So this is something that we have to look at the consolidation part. For example, I don't want to buy infrastructure, but I know there are as many as 150 servers in my data center which is not used. So can I actually try to consolidate few servers into one and then try to use the idle servers for the application? So that is another service level agreement maintenance and management. Then what is the maximum workload the application and the supporting infrastructure can handle? Like this you can do for as a load testing or a performance testing. But if you are using a commercial tool, you are handicapped with the licenses if you're buying an open source tool. However, open source tools like JMeter might not support more than so many users for a little heavy-weighted web application. So you would still want to do some kind of extrapolation and see whether this application / infrastructure would support that kind of load. So these are the kind of queries, and I wanted to set this as a context before understanding capacity planning. I'm sure you all would be having a different kind of understanding of what they are. But however, this is the context that we would be sailing upon for the next 45 minutes. Now, let's look at the current scenario. Yeah, it's flashing on your screen. So now if you look at it, there's a pre-production and there's a production. Pre-production, or otherwise you call it as a performance testing environment, and there's a production. So once you keep finding, do the various experiments in performance testing environment, you test with multiple users, and you do a diagnostics, you drill down and find bottlenecks, and then you try to fix it, or you can see the connection pools, memory leaks, or it could even be so much of a log writing, so much of disk IO. So once you fix it off all, now you are still not aware, and there is definitely a factor of nervousness when you deploy this application in the production. So before you deploy it in the production, you will have to do something in between, and that is where your capacity modeling fits into. So this is something that I wanted to tell you, to just tell how do we position our capacity managers position in the whole of the testing life cycle. So if you look at this, the capacity modeling comes exactly in between to tell. It does a projection, it does a modeling, it just predicts the behavior, and it also tells about what would happen if there is an infrastructure change. And it will also tell whether I'm actually getting the revenue or returns on the investment that I made for the infrastructure, which is I have so much and so much I have invested. Do I get the equivalent performance to this? So this is what is going to be the theory and the science of capacity modeling, which we are going to do. So this is the positioning. On top of that, I've also mentioned on the flash saying which are the typical tools that you use to just give another context as to what we are talking about. So in the production, we use CA Intrascope or HP SiteScope or HP OpenView Manager. There's so lots and lots of tools that we use. So this is something which is little close to people who are aware of what erstwhile tool called High Performance. It's actually a capacity modeling tool wherein that was using more of a load runner performance testing results. Now this is completely standardized, and you can use any tool and you can still do a kind of a capacity modeling and capacity planning. So we'll come to know which tool we are talking about in the latest part of the session. Now look at that. Look at the circle inside and just concentrate on the 5 balloons out there. So these are the typical questions that we would be looking at in this due course. Infrastructure change, the first balloon. So do I have a correct hardware, which means am I having something, do I have a right set of RAM size, right set of disk IO, right set of, CPUs and RAMs. So that is the infrastructure that you wanted to validate, all right? And the second is response time prediction, as you see on your right-hand side balloon. So most of the times you would wanted to see whether the response time at 50 users is so and so. What would the response time be at 500 users? So here in this capacity modeling theory says you cannot actually directly focus that way. However, at the process level, which means let's say if a Java application is running and you see java.exe in your task manager, which is the process or a daemon. Now, there are many instructions this java.exe executes, and these instructions, the response times are gathered, and those response times can be predicted exactly when what happens when the load increases. So what I wanted to tell you is, please let's not confuse this response time with the end-to-end transaction response time as you see in the load runner. Rather, it is the instruction execution time at the process at the daemon level. So that is what a capacity modeling should be used for. Very simple, because a response time, end-to-end response time includes so many factors like a server, the network, and the disk IOs, and so on, so many factors which cannot be included in capacity modeling. So that is the second balloon. Then the third one after response time, which is workload consolidation. As I mentioned there, can I merge these 2 app servers into one? This is something like infrastructure engineers would be looking forward. Most of the customers that we have, they have thousands and thousands of servers. And if you look at the kind of utilization of these servers, I'm sure that more than 60 to 70% of the servers would be underutilized. So there is actually an imbalance in the server farm that the customers provide. So in that case, instead of going and buying a new server for hosting a new application, now infrastructure engineers can make use of this science and then understand as to, can I use the existing hardware itself by consolidating the other unutilized or less utilized servers. So that is workload consolidation. Then the test to production, which is pretty straightforward. How do I compare the results of test environment, which is in this case a performance environment, to the production environment? Then the workload change. For example, let's say there is a retail application like eBay, which is having a constant load, and all of a sudden during Christmas time, we call that as a holiday readiness. During Christmas time, there is a huge load on the server and infrastructure. Now, if there is such a kind of a spike and such an exponential spike, will this particular application handle? So this is a dramatic change of the workload. Now, these are the 5 different contexts that you have to keep in your mind. And as a performance engineer or an infrastructure engineer, if you could add these details in your CapEx or OpEx, which means capital expenses or operational expenses plan, then that would be adding more value to the stakeholder discussion and document committee. So this is the kind of perspective which we would again sail upon. Now let's look at some amount of theory capacity modeling going back to the school days. Let's see. Now look at this. Most of the times, when you actually tell that there is a 10 user load and this is the response time on your y-axis, and the 20 user load and this is the response time with 30 users or 30 seconds. For example, let's assume that you have three data points that you have configured using performance testing. Now, if you go back to the school, then you just join these dots and you can look at there is some kind of a slope coming. So in the school days, you might have heard a formula called y is equal to mx plus c, which means given an x and y, given an x and y, two x and y's, you can definitely find the slope of this. Now using this m as a slope, now you can, for a given x, which is for a given user load, you can definitely predict the response time. Now this can happen if it is a linear modeling, which means 10 users, let us say it is 5 seconds, 20 users, it is 10 seconds. Obviously you can tell 30 users, it is 15 seconds. So this can only work as a linear modeling. But most of the times we know that the applications or infrastructure do not behave this way. So Excel trend, there is a function called a trend that most of the infrastructure engineers even today use. So if you look at it, it's a very, very interesting formula, that trend function in Excel. I repeat, there is a function called TREND, which would actually tell you what would be the next data point that you can arrive for a given X or a Y coordinate. And there is a non-linear modeling also. There is an analytical equation that you can use it for doing it. However, it has to be the smooth curve. If you look at it, the curve at the bottom right, you can see a smooth curve. Now there's such a smooth curve, maybe you can come to one kind of extrapolation point. So this is how typically modeling is done traditionally, which is more a crude way of doing. However, at this moment, we are left with this. So the capacity planning theory, if you look at scientifically, there are 5 different laws on which this capacity planning extrapolation is done. So which are those 5 theories? To the best of my knowledge, which we had used in many projects, these are the 5 different laws. Number 1, utilization law, Little's law, interactive response time formula, forced flow law, general response time law. There are even more laws, around 14 laws are present. So these are the 5 which are major one and has a good impact. If you look at the Pareto chart of 20% of the laws which are actually giving 80% of impact in extrapolating. So this is what I want to do. I'm going to explain 1 or 2 laws so that you get some kind of a hang on, and then the 3 other laws you can probably do your own research, or in case if you wish to know, you can get back to me. I can explain you in one slide. All right. So let's look at the first law, which is utilization law. I'm going to be reading a little verbose one. Let's see. The first law is utilization law, which is equal to, very simple, throughput into service time. Okay, throughput, we all know the number of transactions or number of instructions executed per unit of time, which is typically seconds. So transactions per second into service time. Service time, we don't call it as a response time, we say service time, response time. So now look at an example or an illustration below. Consider a disk with a capacity of 20 I/O requests per second. Okay, average I/O service time is 40 milliseconds. Now, so if x is equal to 20 per second and s is equal to 0. So straightforward math, and the utilization comes to 0.8. So which is into 100 gives you 80. So 80% would be your disk utilization. Now, how do you find out and measure your throughput and service time? You can definitely find out using perf mon counter if it is Windows. If it is obviously the Linux or Linux family or Unix family, then you can get it through vmstat or SAR utility. Now, this is some of the formulas which all the performance engineers and infrastructure engineers should have in their fingertips to understand at any point of time. I'm sure most of the performance engineers would be collecting performance perf mon results, but in terms of correlating one counter with the other counter, that is where we don't do more consistently. So if you want to do a successful capacity planning and if you want to be a successful performance engineer, you might have to follow this theory. Now let's get into law 2, which is Little's law. Okay, a Little's law, in the name of the person who devised this law is called Little. It's Richard Little. So this Little's law, it's not that law is very little, but it's based on his name. Now, what does Little's law tell? Number of requests is directly into the throughput is directly proportional to throughput into resident time. Now, what is an average resident time? Time for all the requests divided by number of completion. So what is being considered here? A request can get into the queue, and not necessarily all the requests will be processed as soon as the request is submitted. The request will get accumulated in the queue, and hence at any given instant of time, there could be requests in the queue, there could be requests under process, and there could be requests which are completed. So with this in the context, the residing time is equal to time for all requests slash by number of completions. All right. So if you want more details, definitely Wikipedia can help you. So this is another law on which the model and science is devised. So which are useful? Only two variables are known. Can be applied to various levels in the system. All right. So this is how the Little's law should be looked at. Next. Now let's look at some mathematics also, so that you get a hang on what exactly a Little's law is. I'm sure you can read it there. Considering a system that is processing 54,000 requests in an hour and average of 7.5 transactions in process during a given period of time. Now, if you want to calculate the approximate response times. Now, using Little's law, which is n is equal to x into r, n is 7.5 that we told, 7.5 transactions, and x is 15 transactions per second. So obviously, the response times would be 7.5 divided by 15, which is half a second. So this is how you will have to use the law and then understand. Now, when I'm talking about the response time, I repeat it. It is not the end-to-end response time. Rather, it is a response time as seen in the at the OS platform level. Okay, so that's the mathematics that we wanted to give you given a context. Now, this is the most important slide. I always like it. I'm going to read it out. Don't mistake me if I'm actually reading out too many. Considering a system running at 10% CPU utilization, if you are told to open an Excel sheet which uses 5% CPU constantly, it would work fine because 10 plus 5, 15% only, rather CPU can run at 100%. Now, assume the same system is running constantly at 90%. And at this moment, you open an Excel sheet which will consume 5%. Now, still 90 plus by 95 and there is still 5% left. But now if you look at the scenario B, the opening Excel when it is 90% will be massively slow compared to opening an Excel which is during the CPU 10%. Now, logically, it has to run at the same speed because there is a 10% CPU and there is 90%, and adding this Excel's 5%, still it does not reach 100. Now, this is very important, and this has to be accounted while planning for capacity. So this corollary, which is coming handy during planning the capacity, is going to make you bring you more subjectiveness and also brings more amount of experience to be accounted for. Now, headroom. Now, if you look at the graph, so the one that is linear that I said here, so linear per se, if you look at, there is a dotted line double arrow header mark. So that much is gap provided is what we would assume so. But the actual trend and actual way the utilization and the headroom means the available space. So if you look at the available space here, which otherwise would have been so big, is only this much now. So if you look at the headroom, that is the actual available space vis-a-vis that should not get confused with the actual CPU utilization. So CPU in use will actually go exponentially at the start, and it will have some kind of a breakpoint and then reach the saturated level. And when it is crossing 80% CPU utilization, it is highly unpredictable. That is why we keep telling this thumb rule to many performance engineers that do not measure anything when it is crossing around 90-95%. If you capture response times or memory utilization during the 90 plus or 95% CPU utilization, then the one that you are capturing are not at all representative. So these are the ones that the performance engineers and capacity engineers should have in a kind of a perspection. So this is one such a case that I would like to tell. And now let's see why nonlinear growth. Okay, so why do systems grow non-linearly? When only a few processor threads are executing, all right, so contention for shared resources such as memory, cache, buses, or whichever it is, are low, and the system resources are utilized effectively. So the time spent in acquiring the resource, for example, if I send an instruction and that instruction or that command needs a resource, for example, a CPU. So if there is less contention, there are no quarrels for the resource, which is CPU, then I'll be able to get some amount of time from CPU. But if there are so many people asking for the CPUs, and that time if you go and ask the CPU resource, hey, can you please come and help me executing this instruction, then there's a greater and greater contention for these shared resources. So more and more time is spent in acquiring these resources, and eventually the time spent is significantly large. That is noticeable. That means you will assume that this particular instruction is taking longer time, but actually not. It is only taking the same amount of time, but the time to acquire the CPU for executing this instruction, or the waiting time for getting the CPU to execute this code, takes longer time, and hence you see, or you perceive it as a high response time. So this is one of the reasons why a non-linear growth or non-linearity is being seen, or exponentially it is seen. Now let's first jump on directly now to capacity modeling, how it is done. I'm going to talk in a very simple words. You just dilute it so that it reaches more effectively as I perceive it as. Look at this. Now this picture, I'm waiting for the picture. Yeah, it came. Now look at this. The first picture test, I do a test at 100 user load. Then at 100 user load, I capture all the server statistics, web app and DB, for example. CPU, memory, disk, and network, which are the 4 prominent and the top resources that I have to capture. So as you see, 20%, 63% memory, disk is 7% or 8%, network is around less than 1% utilization. Which means if it is a 100 Mbps LAN, I'm using 1 Mbps or 0.7 Mbps. Now the similar test, I am actually now scaling up and doing the workload test at 1,000 users. Now also again I capture all the statistics, but this time if you look at the CPU, web server is at 8.84, which was 20. Memory, which is 162, so which means you can clearly understand there is a huge amount of paging that is happening between the RAM and the hard disk. Then there's a disk of 13% that we saw, and the network was utilized to 3% of the actual bandwidth allocated. Now, once this particular test has been conducted, I mean the performance testing has been conducted, and the measurements also we have received it. Now, what we're going to do is, 1 minute. Now look at that. Now I'm going to do a workload growth. So current workload is 1,000 users. If workload increases as below. So for example, every quarter there is a 20% growth in terms of business, which means the number of users hooked onto the system becomes more. So assuming 1,000 users is the current workload. And in the first quarter, there's a 20% growth, which is 1,200, which is until quarter 4, which is 100%, and which is 2,000 users. Now, if this workload keeps increasing, what would be my CPU utilization? Is existing memory enough for next year? Whether disk has the capacity to handle. If the growth is spiked to 200%, am I ready for the support? So these are the questions that are there that keeps bothering you as a performance testing engineer or a capacity engineer. So now to answer all these questions, what do you say traditionally? I'm sure you're looking at the typical solution. You might say increase the memory of the server from 32 to 64 GB RAM. Increase the processor speed in case if it's a core, dual core, or core means core to duo or whatever it is, quad core or whatever. Then you can also say disk controller speed also that can be increased based on if there is a disk bottleneck. Now which servers and network components really need an upgrade? You are completely confused. So you just go ahead and tell that do upgrade all components of the service. So if there should be some signs attached to what you are talking as a solution, you must use some kind of a mathematical or proven formula. And that is capacity modeling. Now let's go to the other question. You are doing a vertical scalability. You are also doing a horizontal scalability. Vertical scalability, we all know it's a one server only, just that you are increasing the capacity of the existing server. How? By increasing the RAMs and increasing the CPU's speed. Now, horizontal scalability, I'm not going to actually extend my server, or I'm going to actually put some more servers into the server farm or data center. And that's horizontal scalability. Now, you can tell that, but before even telling that, do you have some results with you to prove a point to your stakeholders? You might not. So you just dilly-dally between a vertical scalability and horizontal scalability. If you need some kind of a robust numbers with you, and that is attached to a science, and that science is capacity modeling. Now another question. In the recent past, we had been seeing customers coming and saying that, hey, I don't have too many physical servers in my data center or server farm. Now I'm going to just put everything on the cloud. We all know for a single Coke, for $1, you would actually get as many as VMs possible in the typical cloud vendor. Now, don't you tell me, if the application has been working on a physical server for so many years, now you're going to put it on the cloud, which is using this hypervisors, and there could be VMs which is being used by other companies or other enterprises also. Now, how is your application going to behave? Now, if you have to tell, you definitely cannot do any kind of a performance testing or any kind of an Excel extrapolation. You might have to definitely deal with some amount of science and some amount of benchmark figures and references, and that science and science around it is called capacity modeling. Now let's look what this capacity modeling is as a process. Now let's define a capacity modeling. A successful capacity planning is all about knowing how to reduce risk without disturbing the production environment. Now, if you look at the infrastructure, you're going to plan your infrastructure based on user volume, based on the growth that you would be seeing in another 2, 3 years or 5 years or 10 years, because after 2 years, if you think that the servers are useless, then I cannot actually sell the service for actually a resale value is gone completely down. After 3 to 5 years, I think the machines are nowadays not, it reaches the end of life. So when you're planning and buying a server, you're going to actually use your complete, science and complete strategy and complete analysis before you buy one. So you're going to plan your infrastructure based on the server configuration, based on the performance of enterprise applications as well. Like looking at number of tiers, number of distributed network nodes. So these are the important things that you have to see. So I repeat my definition of capacity modeling and planning, which is knowing how to reduce risk without disturbing the production environment. Now, this would be, whose work would this be? This will eventually be a joint collaboration work between performance testing engineers and the capacity planners, which is infrastructure engineers as well. Now, let's look at the approach into a 4-box diagram. As you see, there could be data coming from either the performance testing tool. For example, in this case, I used load runner, or it could even come from any other tool. For example, other performance testing, like you can do a JMeter open source tools, that also provides some kind of results. Then there are performance monitoring tools like PerfMon, SiteScope, OpenView Performance Manager. As you keep doing testing, you are anyway monitoring and measuring the data. And those data, you put it in the dump in an Excel sheet and now give it to a special tool and solution called Capacity Manager. This was erstwhile High-Performix, and Capacity CA Capacity Manager is a new version or a new evolution from High-Performix. Now, what does this particular Capacity Manager do? The first thing, it will just get on to all the entire huge lump of data that you had been monitoring in terms of CPU, memory, and each and every core of a CPU, and disk, network, private bytes, thread, contention, context switching, everything. It just takes and analyzes it and keeps it ready. Then it creates a kind of a model. What does a model mean? A model is something like deriving a formula. For example, let us say if I tell 2 computers cost 20,000, 3 computers cost 60,000, sorry, 30,000. then you can definitely tell how much is a 4 computers cost, which is 40,000. So if you know 2 data points, you are ready with one kind of a small formula, and that formula I can actually extrapolate for a higher values. Now, when you tell formula, that is what is model. So looking at the data points and the way the data points had been incrementing, the manager, capacity manager creates automatically an analytical model using that data. Now, why do I need to create a model or formula? This formula, now I can use it for a higher loads, which I was not able to do test in the local small or the downsized environment. So, and those kind of extrapolation is called what if experiments, the third blue box. And finally, once you have done the what if experiments, you can start doing the analysis of results. So this is how typically a capacity modeling approach should be and would be. Now, now you can ask me, now load runner test results actually provides response time 2.6 per second. Is it any, are we going to use it here? The point here is the load runner or any performance testing tools provides the information on application end to end. But capacity manager would need the hardware data from the monitoring tools. So I'm going to quickly get on to the questions from data analysis. It's preparing a single business function trace and generating the network performance profile, process a single business load test, generate the resource usage summary, create application profile effort, which I told you. The second is the model construction, which means deriving a formula. It is just for which you need to provide some kind of input data like hardware topology, the way the measurements are going up, and to build an application profile. Then the third is what if. It's as simple as prediction. What if the CPU is double the size? What if the RAM is 4 times what it is now? And finally, it's the analysis of results. So something that I've already told is what is mentioned in this slide. So let me go further. Now look at this. Which are the various places I can get the data from? I'm sure on your top left you can see perfmon, S12 performance monitor, and you can see on your right hand side vCenter, which is actually used to see the CPU of the hypervisors. Then on your left you can see the CA Wiley, which is one of the commercial tools to monitor the enterprise applications. Then the black color window, which is the NMON utility, which is AX, IBM's AX as NMON as its monitoring utility. On your right hand side again you can see Hyper-V, which is the hypervisor monitoring. So these kind of data you will know how, you should know how to capture it and then feed it to capacity manager. Now is what I'm going to tell the stuff that I told you even before. So 1,000 users, I'm going to run a true or false test. And please understand that one of the best practices is when you want to do any kind of extrapolation, you have to run the test continuously for quite some time. So in this case, it's 12 hours. It might sound like an endurance testing or a soak testing, but that is how you will have to do. If we wanted the capacity manager to come up with a good-looking analytical formula or a model, then you will have to do a longer run or a longer duration of test. Now what I'm going to do is I have been gathering all the important counters like CPU, memory, disk network, and CPU, memory, disk, and network. So now everything I'm going to put it in one database, and then I'm going to use capacity manager to talk to that database and create a model or formula out of it. Now this is how it is, something that we already have covered, the process. So if you look at this modeling process, it is characterizing the infrastructure. What is characterizing? Like you're gonna give configuration and then kind of configure the actual size of those servers and network or whatever network components are present. Then these measurements that we got is because of this particular workload. For example, 100 users or 1,000 users, something like that. Now, once you create one, then you drive a model and you run the model for various scenarios. Then you run some scenarios and then finally validate the model. So this is how typical process of modeling is. This is another perspective. Now look at this. There are a few examples that I wanted to show. This is an example where I'm telling that month on month I wanted to see the CPU utilization. Now in this case I did a horizontal scaling, which means I replaced the existing server with a high TPP. A TPP means total processing power. It's a combination of your CPU size, networks, disk controller speed and memory, the speed in which the paging happens, etc. And then they come up with one number. So TPP is a function of CPU speed, disk speed, and the memory prominently. So that I can tell that, if this is a server, the server has 355 TPP, which means it means this is the combination CPU. So I am completely removing the server, and I am actually putting another server, okay, and I'm going to check how is the extrapolation. So as you look into the graph, month on month, this is how it is going to go. You are also noting another alert point, which is at 90%, I kept a red color line. So I'm saying that 90% is my threshold, and I don't want that to be crossed. So if you keenly look at your right extreme, 2511 and 2011 here, by the time it has almost reached 60%. Now you can look at this. The graph is actually not looking linear, and there is some kind of hyperbolic nature. So now if you're starting from 24/12/2010 to 25/11/2011, which means 12 months. So from 12 months, it has gone to 10 to 60, 50 to 60. So what if it's going to be in another 1 year? Will it easily touch 90%? By looking at the smooth hyperbolic curve, it would be. However, you might have to extrapolate it analytically by using the model. So this is one such derivation. This is how we try to interpret the graph and try to interpret this kind of modeling for horizontal scaling. Now let's look at vertical scaling. Now what happens is I had actually loaded all the results into the capacity manager. Now what I do is I actually try to increase the RAM size and increase the CPU speed. Okay, because my infrastructure team or my stakeholder has told that we will not be able to procure a server. If you want, you can actually improve the components or the speed of the components inside the server, which means increase the RAM size or the CPU speed. So I increase the RAM from 2 to 4 GB, CPU from single to dual core. Now look at the results. The same kind of server, how does it produce? So still you can see there is some kind of a straightness here, and if you look at this area, the last 4-5 months, there is an actually exponential, which you might not notice in the naked eye. However, that is the actual phenomena. So this is how you see for vertical scaling. Now let's go ahead. Now look at the forecasting the underutilized server. Now you can also say that when you are in this 24/12/2010, it's been used around the 7 to 8%. As you keep proceeding, maybe another 1 year, it's probably use 20-25% CPU. So which means even if it just goes another 1 year, it will go to 40-45. Then 60-65. So another 3 years, I think the server is not going to be used so much. So in an enterprise class application setup, you might want it to use to host the same server for something else as well until a new server is bought. Now this is the kind of decision now I take by looking at this graph. So this is when a capacity manager or infrastructure manager, when they provide some kind of analysis, some kind of a plan, they have to substantiate their sayings using these kind of analysis and models. So this is an underutilized server example. Let's move on. Moving to cloud. What will happen if I move to ESX 5.0 to Hyper-V, which is from Microsoft? Even this is possible by Capacity Manager. You can ask the question like a Capacity Manager is actually a third-party tool, and how would it know that Hyper-V, Microsoft's Hyper-V's performance? Please understand, guys. It's important to know that every hardware that is released into the market will come with its own benchmark as published by the third-party person called TPCC, Transaction Processing Council. So you can go to Google and say TPCC and you can have enough number of information from there. So this is how I do a kind of extrapolation when I move it into the cloud. So if you look at it, the first month there has been a huge jump in terms of utilization, and after that there had been some kind of a smoothness. So if you look at it, at the end, there is last 4 months, if you see, there is some amount of convexiness there. Okay, so again, like I said, it comes with an experience, And if you look at the first, some second month onwards to 7th month, there is some amount of, it's like upward facing circle, and the last 3 months there's an inward facing circle that you can see. Right? So this is the kind of derivations I actually take it from these kind of reports. Now, the app is going 3% every year. When will it break? Okay, you got to be very clear. You cannot actually go and purchase an infrastructure once the servers are broken. It's a complete loss of business. So if you want to really tell us to, I can see that, a new telecom vendor, typically telecom vendor, you clearly tells about the volumetrics. They tell that 15% next year, we can see that many number of callers or subscribers. The next year is 30%. So if it is year on year this much, actually will the server break? If it is breaking, then when will it break? Now as you see in the picture, it clearly tells us the model terminates on 10th of August 2030 perfectly. So 23/11/2011 is the starting point, and I wanted to do the extrapolation until 24/12/2012. But it said I cannot extrapolate further because you have kept the deadline as 90% utilization, and that you can easily reach the 10th of July or 10th of August. So the capacity manager tells that you cannot extrapolate further. So it will stop and it stops there. It just breaks. That's what it calls as model terminates at 10th of August 2013. So this is the kind of an understanding, this is the kind of corollary that I can derive from this one graph. So how will the workload grow? Now if you look at it, there is a combination of all the tiers in one server, which is web server, app server, DB server, and there are other, something like maybe let's say assume there's queue or a batch function that keeps running in the server. Now if you wanted to actually even tell whether there will be a growth only on the web server load or app server load, that also you can tell. Now if you closely look at this graph, when I try to extrapolate from November 2011 to, let's say, to December 2012, there is actually a utilization increase on the web app server side, which is the blue color graph. But on the cream color one, which is the web server, there is hardly any increase. If you look at it, it's more or less it's constant. And DB is not even seen, which means not much of a load. Generally, DB server might not have lots of load because DB servers are all tuned for years together. And if you look at it, the kind of threshold I've kept it is at 90% utilization. Now, you can also understand that from here that, yes, now you may wanted to actually dismantle the app server and put it in some other server. Now, where does the bell ring? The bell rings in the development community saying that now we have to easily remove the, or seamlessly remove the web layer, web tier and app tier. Because app tier is going to hit at a higher load. So this is the kind of corollary that you need to bring. And this forms a development plan as well for the subsequent quarters and subsequent years. Now, where does the performance engineer fit in all this? He is a missing link between the infrastructure team and the business team. The performance guys know what is the business. The performance guys know what is the infrastructure behavior in terms of configuring different workloads. But do they give it to the business team? They can give only to the business team only when they tell in terms of infrastructure and how it is going to really impact the load. So this is how you will have to find out where does the performance engineer fit in. And these are the ones which are very, very common myths. The first myth is something like planning for capacity can be done with an Excel spreadsheet, which is what today 80% of the capacity planners do. They use a function called a trend, and with the trend you can actually do a straightforward linear extrapolation, but you cannot consider the fact that there is always the headroom being very less. And it's always not linear, or it is not at all linear. There's always a curve that comes on. That's the first myth. And the second myth is solving issues at one node on the tier solves quite a few problems. Now don't look at all those kind of wordings there, I don't have time. You look at this web server, app server, DB server is present. And before tuning, web and DB had problems, and now I try to tune web and DB, so now that's running good, and obviously I see more load coming on app server now. Very simple. If in a road junction you try to see so much of traffic and try to build a flyover, and that particular road junction, you can see the traffic getting resolved. Since that is resolved, all the traffic goes faster and then gets clogged in the next traffic junction. And now, if you look at the second diagram, the app server looks as though that is having a problem. So that is one myth. Okay, so if you solve issue at one node on tiers, it solves quite a few problems. That is a wrong assumption. A good performance infrastructure should be like there should be a balance of load across all the tiers. And that is one myth that I would like to tell. Hardware is so cheap that I don't need to do a capacity. I don't need a capacity planning at all. Definitely not. This is something that's coming in most of the articles. But I see it as something like hardware is still not cheap, and there is quite some amount of operation expenses and capital expenses, capex and opex being looked into. That is why the clouds are coming. The fourth one, again, it's a continuation of it, which is cloud infrastructure does not need a capacity planning. I can just pay any amount of dollars and I'll keep getting as much as VMs and as much as this one problem. So it still needs a capacity planning because that is when you can balance the load. So we have seen more problems in cloud vis-a-vis actually the physical service, because physical service is complete in our control. The cloud VMs are not in our control, and there are so many parameters which has actually integration with this. So that is very important myth that has to be looked at. Then the best of the both worlds, performance team and the capacity team. There are a few points that I wanted you to take away as well, which is parallelism. Parallelism enables the applications to perform better. The data passing, there's an imbalance in server configuration, improper communication between tiers. All these are going to impact the performance. And all these are going to make our job so interesting and so fun-filled and eventful as well. So that's all about the presentation. I just wanted to share a few of the thoughts that based on the experience that I had in capacity planning. We have been doing it in various customer ends in terms of designing the capacity, or it could even be extrapolation, or it could be a scale down to design our test environment. So this was the experience that I came across, and I wanted to really share about this. All right, let me take a few questions if they are present. Let me see the questions properly. Okay, there are quite some questions. What are best practices followed in performance capacity planning? I just covered it, so maybe this came at 3 p.m. so by Ramesh. So the best practice that I've already showed, all you have to do is look at the myth and look at a few of the common myths and then see how do we overcome. So myths cover that. So that's my answer. Myths cover those. All right. So the second question is tools that are available, both open source and commercial tools for capacity planning. I will not be able to tell which are the open source ones. They are not really, I have not used it to a great extent, but I can actually tell some of the commercial tools for capacity modeling, like one is the TeamQuest Capacity Modeler, and the second one is CA's Capacity Manager. Okay, so that is what is the answer for this question. Then how to predict when the application is tested in cloud and then pushed to production for GA availability. So predict the application tested in the cloud and then pushed to production for GA availability. I'm not really understanding what a GA availability is. But however, when application is tested in cloud, again, it has its own performance results. It could even be hypervisors. So from those hypervisors, the results are gathered and then loaded into the capacity manager for doing extrapolation. So it is possible using capacity manager, and that would be my answer. And then how much confidence does extrapolation assist us in getting a capacity planning and modeling? This is a very good question. We did quite a number of experiments, and the kind of confidence percentage, we actually put it as an error percentage. Okay, so maybe you can actually understand in different ways, but the confidence percentage is as much as 60 to 65%. So I'm going to just say confidence as 60 to 65% average. And this was for application that had 4 web tiers and 2 app tiers and 1 DB tier. There was 1 queue server as well. That's the kind of confidence that we had on the extrapolation. Are we assuming pre-prod and prod are the same in the infrastructure wise? Definitely not. Definitely not. Pre-prod and prod, because of the ununiformity, is what we do it. So definitely not. So there's no assumption like pre-prod and prod are same. In fact, because they are not same is what we want to do extrapolation and then find out what the problem is. How much we can rely on the performance tools, as each of these tools that's used for performance testing may not provide the same kind of results, and how can we use this for the performance capacity modeling? I don't understand what exactly it means by telling how much can we rely. It may not provide the same kind of results. Honestly speaking, if everything is same in terms of configuration and the environment, the results are supposed to be same, but it will definitely not be same because of the nature of the queue and the nature of instructions being processed. So I would probably say that we run for 3 to 4 rounds and take the concordant results. I wanted to just tell you that go back to the school days where we, in the laboratory, we were actually trying to take 3 to 4 and then take the concordant value, right? So I'll just say 3 rounds and take the concordant value. That would be my answer for this question. How much iterations that we need to perform for a capacity planning when the time to release the application is at high stake? There's no iterations, rather I would probably call it as run a longer duration test. So run a longer duration test. If you run a very shorter duration test, the kind of data points that you feed into capacity manager is going to be not that great. So you will have to run your longer durations, like typically we run for 12, 24 and 36 hours, gather the data and then feed it to the capacity manager. And what does the capacity planning vary for the following? Project-based, product-based, media-based, mobile, non-IT, application for product. No, this is actually, capacity planning is more of a server-based stuff. So there's nothing like a project-based and also I would call it as a server-based. This is a question of what is residing time. The kind of, the time for which a request has been in the queue, and at the same time the request is getting processed. So, which means it is residing time. It's a processing time plus waiting time. Is called a residing time. That's what I would put it shortly. Processing time plus residing time, waiting time. All right. So does all these laws assist in the types of application that is developed? Definitely yes. Because if you look at the application, it's a software that again stands on the hardware. So if you look at these laws, the laws are very closely associated to the hardware, not the application, which is a software application, which is standing on top of it. So the laws are still valid, which we use, since this is associated to hardware. Namely, application in series, application, I'm not understanding the question. Namely, application in series, application in parallel, mix of service and hybrid application. I think it's the same question. How can we determine number of transactions in little law of previous slide? I think that's already covered. Number of transactions is actually as you measure in the performance or any kind of a monitoring tool. So the number of transactions are measured using the monitoring tool. That would be my answer. But just adding more servers and having load balancers will also not assist in capacity planning, I doubt. Well, we didn't say that you have to add more servers. In fact, whether to add more servers or not, if you want to add more servers, definitely where do you need to add? And that idea is given by capacity planning. So where to add and how to position is guided by capacity planning. But when we use cloud, we use as pay, but how do we maintain the same configuration as cost increases as you hold on the service? Maintain the same. But when we use cloud, we use as pay, but how do we maintain the same configuration as cost increases as you hold on service? I'm not really clear with the question. I'll move on with other question. How do we model on network when the application is accessed from different geographic areas? Of course, this is a different question, not with capacity modeling. However, I would suggest for network modeling, you can actually look at OpNet modeler. Okay, this tools and solutions will give you more picture on how does it behave from different geolocations and different kind of latency and jitter factor. How much involvement is needed from the business analyst for assessing the performance? Of course, we need business analysts, to understand the growth, to understand the workload growth for coming years, for subsequent years, and have an understanding about the sponsor committee. I mean, this is the practical answer because we have been contacting business analysts. Say, hey, can they actually sponsor more servers? if they do not, maximum what is that they can do. So business analysts really are helpful for us in terms of getting a decision. We'll only reliability testing assessment and capacity planning as understand that there are conducted finding memory leaks and CPU issues. There's nothing like we don't name a testing for only finding so and so. Memory leaks can even come when you do manual testing also. Okay. So reliability, there's nothing called a reliability testing I'm mentioning particularly in this seminar. I would call it as actually a long duration or endurance kind of testing. Okay. So I'm leaving that question that way. When analytics server does not support the information for capacity planning. Again, I'm not getting this question probably. Analytics server does not support the information for capacity planning. I'm not very clear about the question, so might as well I leave this question as it is. All right, so these are the questions and answers that are posted, and I hope I had been able to share whatever we did as in the practical basis in different customer ends. And we also see the capacity planning and modeling is a very, very evolving one, and it would definitely need more understanding of various tiers, various application, various dynamics of application infrastructure. So that's all about it, and thanks very much for a wonderful time, and it has been really, really a great experience for me in sharing my thoughts. I'm sure if you are able to take even 3 to 5 bullet points and take away, I think that I would be happy about it. So that's all about this one. Over to Mohini. Mohini, are you there?
Well, thank you so much for the insightful presentation, Mr. Uday. Thank you for answering the questions as well. This was a great session. I would also like to thank all our participants for the support in making this webinar a success. The recording of this session would be available on techgig.com by evening. Thank you all. Have a great day.
Thank you very much, Mohini.